Welcome, significant fellow. This is Mr. Simplicity, and today we'll be looking at the topic differentiation from first principle. If we're given y or f of x, for instance, if f of x is given to be whatever function of x, then your differentiation, which is f prime of x or dy over dx, is equal to limit as data x tends to 0, f of x minus plus data x minus f of x all over data x. So this is the formula from first principle to solve any to differentiate any problem given to you. So we are going to look at this how to apply this formula to different examples. Okay, this is the summary. Most times solving it directly with the formula can be problematic. So what we are going to do, we are going to take it step by step until we get to the point of the formula. Okay, in breaking down the formula into steps, you discover that it starts from the question that was given that says f of x equals to whatever function. Okay, so the steps are normally used in solving problems on a first principle if the question has been given as f of x, which is the same thing as y. The next thing I do is to add change in x to both sides. So this becomes f of x plus change in x. So what I just did here is that I added data x to both sides. So this is the second step, to add data x to both sides. Then the third step is to take the difference between the second and the first. So if this is equation 1 and this is equation 2, then the third step says equation 1, which is equation 2 rather, which is f of x plus change in x, minus equation 1, which is f of x. So this means equation 2 minus equation 1. That's the third step. And usually when I get to the third step, which is equation 2 minus equation 1, I simplify whatever I get there to the point where I can factorize data x out. Okay? As soon as I factorize data x out, which I usually refer to as a free data x, I go to the fourth step. The fourth step says everything we have in the third step, which is f of x plus dx minus f of x divided by data x. So what that means is that I have, I have equation 2, or rather, let me just say, I divide through by data x. So that is exactly what happened in the fourth step. And the essence of the fourth step is to cancel out any free data x that is still in your expression. That's why I have to solve the third step until I have a free data x. Okay? Then after you have done this, you will now get to the final step where you are applying the formula, which says that limit as data s tends to 0, f of x plus change in x minus f of x all over change in x. So this is the same thing as your dy over dx or your f prime of x. So this is the final step. Though your final step, you can still simplify depending on whatever you have there. Maybe cancel out something and you get the final answer. So these are the steps when solving your first principle. So let's go to our very first example for this topic. So I'm going to start with f of x equal to x. F of x equals to x. So if you remember the steps I've given you, step 2, the question is now the first step. Step 2 says add change in x to x. So we're going to, anywhere we see x, we are going to replace it with x plus change in x. We are not just adding x to everything directly, but instead, anywhere you see x, we immediately expand. That x will be removed and be replaced by x plus change in x. So in this case, I'm seeing x in this bracket. So which means this bracket will expand to become the second step, x plus change in x, equal to this x will expand to become x plus change in x. So this is my equation 1, this is my equation 2. You don't necessarily need to write the equations. So the next step, you will discover that we can now subtract equation 2 and equation 1. That's equation 1 from 2. So that means that will now bring us to the third step, f of x plus change in x minus f of x, which means this x plus theta x minus this x. So I told you at this step, I will simplify until I have a free theta x. So if we simplify this, x minus x will cancel out. So x minus x is gone. So what is remaining is theta x. A free theta x standing alone. So we are good to go to the next step. Do you understand? I told you simplify until you have a free theta x. And we already have a free theta x in this case. So we are very quickly, let's move to the fourth step. The fourth step says everything is step 3 divide by theta x. Do the same thing for the other side, theta x over theta x. Okay? So at this point, theta x can cancel out theta x and it will give us 1. So the next step, we're taking limits as theta x tends to 0, f of x plus theta x plus, rather, minus f of x over theta x equal to, what this stage means is that whatever you solve here, sometimes when you finish solving, simplifying this part, you might still have theta x. At this stage, theta x becomes 0. That's what it means. Limit as theta x tends to 0, which means if there's still any theta x left at this stage, let it be 0. So since there's no theta x left at this stage, this is 1, which means our f prime of x is 1. So that is how we solve problem on limit. So every other case I'm going to solve, you will discover that the major work is done at step 3. Okay. So the next example we'll be looking at is f of x equals to 2x plus 5. So just like we said, we move step by step. From what we explained in the previous example, or when we're introducing the topic, the second step says anywhere you see x, replace it with x plus change in x. So I'm seeing x here, it becomes x plus change in x. I'm seeing x here, it becomes 2 times x plus change in x. There is no x here, so that guy remain alone. That's what it means. So you move quickly to the next step. The next step is equation 2 minus equation 1. I have f of x plus theta x minus f of x. So it means that equation 2, which is 2 times x plus theta x plus 5, minus equation 1, which is 2x plus 5. You see it? So what I need to do is to open up the brackets. Remember, I'm simplifying at this stage. So if I open this, I have 2x plus 2 theta x plus 5 minus 2x minus 5. 2x minus 2x is gone. 5 minus 5 is gone. So what is remaining now is 2 theta x. And very interestingly, we have a free theta x now. It's a free theta x because in the next step, as I divide through by dx, it will cancel out. So now I have fourth step, everything in step 3 minus f of x divide by theta x. So this is equal to 2 theta x over theta x. And as you can see, peacefully theta x is gone. What is remaining now is 2. You see? Still the same procedure. Now, the final step, which is taking limit as theta x tends to 0. So taking limit as theta x tends to 0, everything in the fourth step, f of x plus theta x minus f of x all over theta x is equal to, remember this step means if there's still any data x is 0. Since there's no data x, we write what we have there, 2. So therefore, f prime of x is equals to 2. So this is our answer for this case. So I believe as we solve more example, it gets clearer and clearer. So we're going to take enough example for this topic. And if you have any example you want to suggest that we solve, please feel free to send it across and we'll look at it together. Okay, so let's look at this example. In this example, we have x squared. So this becomes f of x plus change in x equals to x plus change in x all squared. One of the common mistakes people make here, they'll put x squared plus change in x. That's why I say you are not adding change in x to both sides. Rather, you are replacing x by x plus change in x. Do you understand? This x is squared. So if I replace x with x plus change in x, it means x plus change in x will be squared. The previous example where we have 2x, 2 is multiplying x. So if I'm changing x, 2 will multiply everything it becomes. Do you understand? So now we can move to the third step, which is f of x plus change in x minus f of x. So this simply means x plus change in x all squared minus x squared. So as I told you, this is the third step, the main step as far as I'm concerned. Getting here shouldn't be a problem from any calculus student if you are following my procedures. So what you need to do at this point is to simplify this expression. Since there's a bracket carrying a power, what should come to our mind is expanding that bracket. And instead of expanding the bracket in my work, I prefer that you know the expansion for a plus b all square and a plus b all cube. If you know those expansion, you don't need to start expanding in your work because you just replace them and keep solving. So I'm going to put them on the board so you take note of them. The first one says a plus b all square is equals to a square plus 2ab plus b square. Then a plus b all cube is equals to a cube plus 3a square b plus 3ab square plus b cube. Okay, so these expansions are necessary when you are dealing with anywhere you see s square or s cube. So knowing them will make your work easier. So take note of them and we'll be solving the case that involves s cube shortly. So with that in mind, I can quickly come here and say this is equals to x squared plus 2x data x plus data x all square minus x square. That means if you use that expansion, this is what you will constantly get. If possible, you might want to master it as what I just did. X plus data x all squared is equals to x squared plus 2x data x plus data x all squared. So I just replace a and b in the expression that I recorded earlier, and that's what we have used here. So let's see how far we can go with that. So with that now, I can say x squared minus s squared is gone, leaving us with 2x data x plus data x all square. I don't have a free data x here. Data x is tied up here, data s is tied up here. So I can free one by factorization. So that means I'm going to have data x into 2x plus data x. So now I have a free data x. Like I always say, that's the essence of simplifying in the third step. So now I can move to the fourth step. And the fourth step is to divide what you have in the third step by data x. So which means I'm going to have f of x plus data x minus f of x divided by data x equal to data x bracket 2x plus data x divide by data x. So you notice that data x is gone. So what we have left is 2x plus data x. Now always whenever I cancel, I must write what is left. Okay. So now I can move to the final step, which is taking limits. So limit as data x tends to 0, our formula comes in. we have f of x plus data x minus f of x all over data x to be equal to 2x plus 0. Remember, I said that's what this final step comes to do. It comes so that anything that is still data x in the fourth step will be changed to 0. So now my data x is 0. So what I have left is 2x. Therefore, f prime of x is 2x. So that's the solution to this problem. So we'll move on to the next example. So this time around, we are looking at case that involve x cubed. So when we see case that involve x cubed, it means we need to remember the expansion I gave in the previous example. So let's see what this will give us. So if we follow the procedure again, we are going to have f of x plus change in x to be equals to x plus change in x all cubed. So f of x plus change in x minus f of x will be equals to x plus change in x all cubed minus x cubed. Okay, then the next we are going to have to expand this. If I expand that guy, I'm going to have x cubed plus 3x squared data x plus 3x data x squared plus data x all cubed then minus x cubed. So all this is the expansion for x plus data x cubed. Okay, so from here data x cubed is gone. X cubed is gone, so we now have 3x squared data x plus 3x data x all squared plus data x all cubed. So data x is common. Since data x is common, we can have free data x, right? So let's bring it out by factorization. Data x will now leave us with 3x squared plus 3x. One of the data x is gone, remaining 1. 1 is gone, remaining data x all squared. So now we can move to the next step. And the next step is to divide through by data x. So if I apply that, I'm going to have f of x plus data x minus f of x all over data x, which is equal to everything I have above, data x into 3x squared plus 3x data x plus data x all squared all over data x. So now the free data x can go. Then we'll move to the next step, which is to, okay, let's write out what is left. What is left now is 3x squared plus 3x data x plus data x all squared. So that's what is left. So the next step as usual is to take limit as data x tends to 0. So let's do that. So limit as data x tends to 0, f of x plus change in x minus f of x all over data x becomes 3x squared plus 3x times 0 plus 0 squared. Okay, so what is left now is 3x squared. That means f prime of x is 3x squared. You see? So that's how you solve problem that involve x cubed.